Alright, let's have a look at question number 9 from the vector homework. It says the diagram below shows position vectors OP and OQ. So this is position vector OP and this is position vector OQ. You have to remember that a position vector is a vector that is tied to the origin. A position vector is a vector that is tied to the origin. Additionally, you must remember that for a position vector, the coordinate and the vectors have the same value. So for example, P is the point 3, 2, and the position vector OP is 3 right, 2 up, so it's also 3, 2. So the position vector and the coordinates have the same value. So the position vector of P and the coordinate, the column vector OP, which is a position vector, and the coordinate P have the same value. Both are 3, 2. So A, we're asked to write as a column vector in the form XY, I, OP. So what is OP? And this is A. OP. In moving from O to P, I'd have to move 3 right and 2 up. So this is 3 and 2. Remember that the top value represents horizontal movement, and the bottom value represents vertical movement. Horizontal, if you move to the right, it's positive. If you move to the left, it's negative. Vertically, if you move up, it's positive, and if you move down, it is negative. So since we went right and up, both values are positive. Now the position vector OQ. Now in moving from O to Q, I have to go 1 to the left, so that top value is -1, and I went 3 up, so the bottom value is 3. Alright, so that is A. Now the B part of the question says the point R has coordinates 8, 9. Well, that's not on the diagram at all. It's not on the diagram. And I couldn't, based on how we draw it, we couldn't put it in. But we know that it would be somewhere out here, 8, 9, it would be somewhere out there. Alright, but we can't put it in. But we know that that R, so this is the B part, and we know that R is the point 8, 9. Now it would have been good if we could put it in, because then we could have a visual appreciation of what we're doing. However, I suspect that we will be able to work the question without having the ability to represent R on our diagram. It says express QR as a vector in the form XY. So BI. So this is BI. We need the vector QR. Remember, I've been saying that in vector, whenever you're asked to find a vector, most time you're going to use the triangle law of vectors. Most times. So QR would be equal to QO plus OR. So we're going to start at Q and end at R, and the next letter is in the middle. We know OQ already. Alright, first of all, OR is equal to 8, 9. OR is 8, 9. Now, OR is the position vector of the point R. OR is the position vector of the point R, and we already established that the position vector and the coordinates have the same value. So since R is the point 8, 9, the position vector OR is also 8, 9. So QR would be minus 1, 3, which is QO. OQ is -1, 3. For it to be QO, you have to be going in the opposite, the other direction, so you put a minus before it. OR is what? 8, 9. So this is 8, 9. So a negative times a negative is a positive. 1 plus 8 minus 3 plus 9. So QR is actually 9, 6. QR is 9, 6. It says using a vector method, show that OP and QR, OP and QR, OP and QR are what? Our OP is parallel to QR. Alright, so QR is 9, 6. Alright, it's easy to see that 3 is a common factor, so I'm going to put 3 outside. I'm going to divide everything inside by 3. 3 into 9 is 3. 3 into 6 is 2. So QR is 3 times the vector, 3 times the vector 3, 2. Now OP and OP is 3, 2. Now, therefore, OP and QR are parallel vectors because they are scalar multiples of the same base vector. So QR is 3 times the vector 3, 2, and OP is the vector what? 3, 2. So the two vectors have the what? Same what? Base vector. When two vectors have the same base vector, we say that the two vectors are parallel. Or so the two vectors are scalar multiples of the same vector. This is 3 times the vector 3, 2, and this is 1 times the vector 3, 2. When two vectors are scalar multiples of the same vector, the two vectors are parallel. Then what else are we asked to do? We're asked to watch. So we do that. The third part says, determine the magnitude of vector PR. Determine the magnitude of vector PR. So let's find the vector PR. The vector PR. No, the vector PR. I don't think we did this. We didn't do it. The vector PR would be the vector PO plus OR. Now PO would be minus 3, 2, and OR is 8, 9. So this is minus 3 plus 8, minus 2 plus 9. So this is 5, and what? 7? 5, 7. So the magnitude of the vector PR would be the square root of 5 squared plus 7 squared. This is square root of 25 plus 49. Now 25 plus 49, that is what the square root. So this would be the square root of 74. And if we use our calculator, we could easily find out the square root of 74. It's 8 point something. Alright, so let me see if I can find that out quickly. So the square root of 74 is 8.6. So the magnitude of PR is 8.6 units. The magnitude of PR is 8.6 units.